Alright, welcome back to the channel. In my previous tutorial, I explained this very example, but I'll leave this 5 as a classwork or as assignments as a take home. But after this video, I'm still going to solve it and paste it here. So in this video, what I'm going to be solving is to prove that for all a, b, and r, that absolute value of a minus absolute value of b is less than equal to absolute value of a plus b, and that is what we're going to be jumping over to now. So now, to show this, we improvise by doing the below. We know that a plus 0 is equals to a, and minus 1 plus 1 is equals to 1 minus 1, which is equals to 0. So now we can improvise by adding a black hole. A black hole is just 0, just adding 0 in any form we see fit. So now the form I see fit here is minus b plus b to be equals to b minus b, which is equals to 0. Now I say recall that absolute value of a is equals to a, and a is equals to absolute value of negative a. Recall we have done something like this before. So now, and absolute value of a is equals to plus or minus a. So now here I said absolute value of a is equals to absolute value of a plus 0, and that's my 0. Here is my 0, but what I actually used as my 0 is b minus b, and that b minus b here is going to give me 0. So that implies that absolute value of a is now less than or equal to absolute value of a plus b, now plus absolute value of negative b. This is the triangular inequality. So now, which implies that absolute value of a is now less or equal to absolute value of a plus b plus absolute value of b. Since 1.3 holds this particular one here, since it holds, so that is why we can be able to say that absolute value of a less or equal to absolute value of a plus b plus b. So now it implies that absolute value of a minus absolute value of b is less than a plus b. That is the first phase of it, and we have gotten that absolute value of a minus absolute value of b. We have gotten that absolute value of a, which is this one, minus absolute value of b, which is this one, is less than absolute value of a plus b. Now, since we have done that for a, we do the same thing to b. So absolute value of b is a black hole, which is a minus a black hole, which is a minus a plus b, a minus a plus b, which implies that absolute value of b is less than or equal to absolute value of a plus b plus absolute value of negative a. And also, since equation 1.3 holds, we can say that absolute value of b minus absolute value of a is less or equal to absolute value of a plus b. Now recall that recall equation 1.4, that absolute value of a is equal to plus or minus a. Now, since why it is equal to plus or minus a is because absolute value function is a non-negative function, and it returns 0 or positive value to any given value. Even if the value is negative, it just behaves like the square function. So absolute value of negative 2 is equals to 2, and absolute value of 2 is equals to 2. So we consider both the negative part and the positive part of it. So now here here. Absolute value of negative a plus absolute value of b is less than a plus b. Now recall, the absolute value of a is plus or minus a, and minus a plus b can be written as negative bracket absolute value of a minus absolute value of b, which is what we have here. See that this thing from here now down to this very place is the same thing as we have from here now down to this place. So we can actually say that absolute value of a minus absolute value of b is less than or equal to absolute value of a plus b, and negative of the same absolute value of a minus absolute value of b less than or equal to this. So we can say that since absolute value function is plus or minus of that value, we can say that the absolute value, which is this is negative and here is positive, the absolute value of these two things, this is 1, the absolute value of this now has covered the absolute value, all right, is now less or equal to a plus b, since the two of them are less or equal to a plus b. So that completes the proof. If you don't understand anything, if you don't understand it well, do well to leave a question down in the comment section, and once I see it, I will attend to it and get back to you. And this is where we're going to stop for today's lesson. Thank you very much. I remain on Research Timothy. Do well to like, subscribe, and share.